respiration, right? So now what is basically respiration? Basically respiration is a biochemical reaction, or you can say it is a metabolic activity in which glucose breaks down to give energy. So basically this respiration is a metabolic activity in which glucose, which is C6H12, breaks down to give energy in the form of ATP, which is adenosine triphosphate, right? So in the form of basically ATP, the energy in the form of ATP. So basically respiration have three steps. First of all is glycolysis, which is the our first step. Then second step is basically the Krebs cycle. This is the Krebs cycle. This is the second step, and third step is electron transport chain, right? So this is the third step, which is the electron transport chain. Second is Krebs cycle, also known as citric acid cycle, and the first is glycolysis. So today in this video we will discuss about the glycolysis, about actually the first step is glycolysis, and it occurs in the cytoplasm. It basically occurs in the cytoplasm of the cell. It occurs in the cytoplasm, right? So now let's discuss the respiration, the first step, which is glycolysis. So basically here the glycolysis is a series of 10 chemical reactions. So basically it is a basically this glycolysis is a series of 10 chemical reactions. So it is a complex reaction, a series of reactions, and this glycolysis is basically also known as EMP pathway, which means EMP stands for Embedden Meyerhoff Pernas. So basically this EMP stands for Embedden Meyerhoff Pernas pathway. So stands for this. So basically the first product is basically glucose, so it utilizes glucose first. So basically there are steps of two steps of glycolysis. So basically the first is basically the preparatory phase, or you can say it is the investment phase. Second we have, which is oxidative phase, right? So now let's start preparatory. So now let's start with the first step of glycolysis. Let me write here. Okay, consider that here we have glucose, right? Let me, so consider this, here we have glucose, and we are converting this glucose is basically now converted into glucose 6 phosphate. Glucose is converted into, here we have glucose whose formula is C6H12O6. So this is formula of basically glucose, right? This is formula of glucose. This glucose is converted into glucose 6 phosphate. So here we write the details of the all the step. Here we write the details. So here we have step number 1, which is what happened basically. This glucose is converted into glucose 6 phosphate. It means that a phosphate is attached. It means phosphorylation is being done. So it means that ATP is used, and ATP, so basically ATP is converted into ADP, and one phosphate has been utilized over here and is attached to this. So enzyme used to do this is hexo hexokinase. Okay, remember one thing, that whenever there is activity of ATP, we will use the enzyme kinase, right? So as you can see over here we have utilized one ATP to form glucose 6 phosphate. So an enzyme known as hexokinase has been utilized over here. Okay, kinase we have put here because there is the involvement of the activity of ATP, and hexo because this glucophosphate is basically attached on the sixth carbon of this glucose. So that's why hexo means sixth. So here on the first step, as you can see, let's mark. This is a first step, and the glucose has been converted into glucose 6 phosphate. Okay, this process must be taken place in the presence of magnesium ions, because these magnesium ions basically provide the stability to the chemical reaction. So whenever there is involvement of ATP, magnesium ions will be used over here. So this is the first step. Second step which we have is, okay, here we have glucose. Glucose is converted to glucose 6 phosphate. Now this glucose 6 phosphate is converted into fructose. This is converted into fructose 6 phosphate. So basically this glucose 6 phosphate is now converted into fructose 6 phosphate. Okay, here we use the enzyme basically, which is known as phosphogluco phosphogluco phosphoglucoisomerase. So here we used the enzyme known as glucoisomerase. So as we know that glucose and fructose both are isomers. So what we have just done, we have just converted a glucose, which is isomer of fructose. So we have just interconverted them. So glucose 6-phosphate is converted into fructose 6-phosphate, right? Now what will happen? Basically, this okay. Now this fructose 6-phosphate will phosphate will be converted into fructose 1,6 phosphate. Okay. Now basically this fructose 6-phosphate will be converted into fructose 1,6 phosphate. Basically 1,6 bisphosphate, because here we have two phosphates. 1,6 bisphosphate, right? So this is done by the activity of ATP, as ATP is involved in this. ATP is, is converted into ADP, and there's a process of phosphorylation, and on the presence of the enzyme. Okay, which enzyme can present? Okay, as you can see, there is activity of ATP. So there must be some kind of kinase. So here we have phosphofructose kinase. Here we enzyme we have phosphofructose kinase. As I said that when there is an activity of ATP, we will use the word kinase, right? So now this fructose 6-phosphate is converted into fructose 1,6 bisphosphate. Now actually there is a twist. So here it is, this all was let me enlarge this. This all was the preparatory, or you can say the investment phase. This all is investment phase. This is investment. This is investment phase, right? So now let's come into the oxidative phase, right? So now basically what happens, this fructose 1,6 bisphosphate is converted into two sugars. Okay, this is fructose. Okay, remember this thing, that fructose is 6 carbon sugar. Now it is broken down into 3 carbon molecule. Here we have 3 carbon molecule, and here we also have 3 carbon molecule, right? So basically now here is a compound known as 3-phosphoglycerate. Now this fructose 1,6 phosphate, this phosphate is divided into, it is bifurcated into two compounds. One is 3-phosphoglycerate, which is basically an aldehyde. It is converted into 3-phosphoglycerate, and then another compound is known as dihydroxyacetone. So now, and this is basically ketone. So basically, this fructose 1,6 bisphosphate, this is fructose 1,6 bisphosphate, is converted into two types of sugars, which are both 3 carbon 3 carbon. Fructose is basically 6 carbon sugar, and there was one molecule that's converted into 3 phosphoglycerate, and another just dihydroxyacetone. So both are compound, and both are actually inconvertible. They can be converted to each other. So here the reaction actually stops. Here is reaction stops, so it can't go further. So this actually these both are interconvertible. So this dihydroxyacetone is converted into 3-phosphoglycerate. So here we have now two molecules. We have two molecules of 3-phosphoglycerate, right? Now this 3-phosphoglycerate is then converted into now this 3-phosphoglycerate is basically converted into 3-phosphoglyceric acid. So it is converted into 1,3 bisphosphoglyceric. Actually, what happens? There's an oxidation of 3-phosphoglycerate. Actually, oxidation means okay, whenever an aldehyde is converted into acid, there is oxidation, and whenever an aldehyde is converted into acid, whenever aldehyde is converted into acid, it's known as oxidation. Whenever the acid is converted into aldehyde, it's known as reduction. So basically, this 3-phosphoglycerate is converted into 1,3 bisphosphoglycerate, or you can say glyceric acid. Right now, this 3-phosphoglycerol is converted into 1,3 bisphosphoglyceric acid. Actually, in the mid of this, a phosphate is attached. A phosphate and attached, and as I said, there's oxidation means a lot of like what happens in oxidation. Basically, electron is lost, a hydrogen ion is lost, and a lot of energy is produced, right? So through that one energy, NAD NAD positive is basically converted into NaDH, right? So as I said, there are two molecules of this, so here will be two, here also will be two, so these also two molecules. So here what happens, 3-phosphoglycerate is converted to 1,3-bisphosphoglyceric acid. So and two NAD are converted into NADH, and one pyruvate also attached. And here the enzyme utilized is known as dehydrogenase. As you can see, whenever there is conversion of NAD into NADH, it means there is an enzyme known as dehydrogenase. Okay. Now what happens? This is 1,3-bisphosphoglyceric acid. Now what will happen? This 1,3-bisphosphoglyceric acid is converted into 3-phosphoglyceric acid. It is converted into 3-phosphoglyceric acid, and here the enzyme utilized is known as transferase, and basically this is transferase, and here one ATP is lost, one phosphate is lost, so here ADP is converted into ATP. So how many molecules? Basically, two molecules. And we have two molecules of this 3-phosphoglyceric acid, 2, right? 3-phosphoglyceric acid. Now what happens? This 3-phosphoglyceric acid is converted into 2-phosphoglyceric acid. Like there is a change in the position of phosphate. This is converted into 2-phosphoglyceric acid, right? This is converted into 2-phosphoglyceric acid by the help of enzyme known as mutase, right? So by the help of enzyme mutase, this 3-phosphoglyceric acid is converted into 2-phosphoglyceric acid. Now what happened? This 2-phosphoglyceric acid is basically converted into 2-phosphoenol 2-phosphoenol pyruvic acid. This is converted into 2-phosphoenol pyruvic acid by the realization of, like, the water is released through this. And how many molecules are there? Basically 2 molecules, as there are also 2 molecules and 2 molecules of 2-phospho. Now what will happen? Actually the enzyme used is enolase, something like this. So the enzyme here used is enolase. Yes, the enzyme used over here is enolase. Okay, now what happens? This 2-phosphoglyceric enol pyruvic acid is converted into pyruvic acid. Is converted into pyruvic acid. Actually 2 molecules of pyruvic acid, actually by like here ADP is converted into basically ATP. ADP converted into ATP over here. So 2 molecules over here, 2 molecules over here, and on the finally in the end we got the pyruvic acid, 2 molecules of pyruvic acid. So as you can see over here, this whole is a series. So here the glycolysis ends. So this whole is a series of 10 chemical reactions. So it starts from this glucose and it ends with pyruvic acids. So let's start. So let's make a equation for this. So what happened? We used 1 molecule of glucose plus we utilized basically 2 ATP, right? We utilized ATP. Moreover, yes, this, then what we got is basically we got 4 ATP plus we got, oops, we got 4 ATP plus we got 2 NADH plus we got two molecules of water, and what else we got? Yes, we got two pyruvic acid. So basically, we got four ATP over here, but we also utilized two ATP in the beginning, and then we got four. So it means the net ATP which we got is like net ATP is equal to 2. So net ATP which we got is 2 ATP, right? So I hope this process of glycolysis is clear to you guys. If you have any kind of questions, you can ask me. I'll be very happy to answer you guys. You can see over here in this picture too.